I wanted to give you a brief overview on how to work through the procedure for the first wet lab. So we're going to look and focus on the metric system, doing some conversions, looking at the precision and measurement, and basically getting used to the equipment that you're going to be using throughout the course of the semester. So at the beginning of the procedure, you can find a list of equipment that you're going to need for the lab. So in this case, we're going to need a camera, ruler, a graduated cylinder, a digital scale. You are going to make some measurements with water, a penny, and you can use a beaker to hold that water. And it's not essential, but an eyedropper makes this lab go a little bit smoother as well. Okay. So we're going to be making some measurements in the metric system. So we're going to be using a ruler to measure in centimeters. We're going to be using a graduated cylinder to measure in milliliters, and we're going to be using a digital scale to measure in grams. And so those are some units that we're going to be using, and then using those measurements, making some conversions throughout the metric system. Okay. Now, every tool that we use has a different amount of precision in the measurements that we use, and that all depends on the markings between the scale. Okay, so each of the divisions and the number of divisions that are present help us to tell how many decimal places we can read our tool. Okay. So the more divisions that we have, okay, the better our precision in our measuring. The less divisions, the smaller our precision. And so that place, that plus or minus, has to do with the first place that we're making an estimation on our tool. And so our graduated cylinder, same idea, we have divisions between those measurements. Okay. You are also going to be using a balance. Okay, so you have a digital scale. You may have to add the batteries to your digital scale. If that is the case, on the very back there's a place that you can add your batteries. And so we will be using that digital scale. I'll show you how to do that in just a minute. Okay. So many times we're going to make measurements, and especially with liquids, we can't measure the liquid directly on the scale. We may have to put it into a container. And so this is what we refer to as mass by difference. So we're going to need the mass of our empty container, empty dry container. We're going to add our liquid into it, and then measure the mass again. And the difference between those masses is what we call the mass by difference, and how we find the amount and the mass of the liquid. We are going to be doing some error analysis, so experimental value, so that's a measurement that you are measuring in the lab. Theoretical is the accepted or given value that has been determined. Okay, and so we can find percent error by doing a calculation. Every time we make measurements, there is always room for error, and so you are going to look at some different types of errors that can happen throughout the course of the lab as well. All right, let's talk a little bit about the procedure. So one very important thing throughout the course of these labs, even if we are just measuring water, okay, we want to get in the habit and we want to make sure that we're safe. And one of the biggest things that we can do to ensure our safety is to be wearing our safety goggles. So you want to make sure that anytime we're working on these wet labs, I'm going to put mine on right now, we're going to put those safety goggles on and wear them through the entire procedure of the lab. This particular lab, we are going to be working with water. Okay, so all of the chemicals, all of the water that you use can go down the drain. The very first part of the lab, we are going to be looking and thinking about safety, because safety in the lab or wherever you're doing science is essential. And so I want you to take a picture of the workspace that you're working in, okay? And then think about, if an emergency were going to happen, what steps would you take in order to remedy that emergency situation? And you're going to record that in your Excel sheet. There is also, at the end of the lab, there's a place for you to collect data and kind of think of and jot down your thoughts as well. Okay, this also includes places for measurements that you're going to make. The second part of the lab, you're going to be looking at the uncertainty in those measuring tools. So you are going to be looking at your ruler, okay, deciding how many divisions are between the different marks, what that uncertainty is, and you're going to be recording that. Same with our graduated cylinder and also the digital scale. Okay. For mass by difference, talked a little bit about that already, but we're going to use our scale. So we want to turn it on so that we get a zero reading. If it does not read zero when you first put it on, there is a tare button. And tare, by pushing tare, that makes the scale set so that it reads zero. You can then add your graduated cylinder and record the mass of the empty dry cylinder. This is where the eyedropper comes in pretty handy. You can add water to the mark that's indicated in your procedure, and you want to try to add it as accurately as you can to that mark. And then you are going to weigh that graduated cylinder again and record the mass and find your mass by difference. Okay. All right. We're also going to be making some measurements so we can do conversions. So one of the measurements is we're going to take our penny. We're going to get the mass of our penny. Okay. We're going to use a ruler and find the diameter of our penny. Make sure that you're starting at the line that indicates zero on the edge of your penny and make that reading. Okay. And then we're going to do some conversions as well, converting them into different metric units. For section 3, we're going to be finding the density of water. So again, we're going to weigh our empty dry graduated cylinder. So make sure that after you do your mass by difference, you dry it out so that we do have that empty mass again. We're going to weigh it. And then we're going to add some water as indicated in the procedure. And again, you want to add it the exact amount, so you can add approximately the amount recorded, but make sure that you're reading it off of the graduated cylinder at eye level as accurately as you can. So you can record that volume that you read as the actual volume. And again, there's spaces in the at the end of the lab to make your readings. Okay, and then you're going to weigh it and record its mass. Okay, you're going to go to the next reading, add the same amount of liquid. Okay, so you're going to increase the amount of liquid. So if you started with 2 milliliters, our second reading, we're going to add more water. Okay, so that we're at 4 milliliters, and we're going to, again, record that volume very accurately, or as accurately as we can, and get the mass. Okay, and you're going to repeat this until you get all of the readings for your water. Okay. All right, so our goal with that part of the experiment, once you have all of the volumes, is to make a graph so that we can determine the density of our water. And there are step-by-step instructions for you in this procedure in order to make the graph. So you can follow through the procedure, make your graph. There's a few questions to answer about types of error and what the different values mean. Make sure as you're making those graphs that you're including a title that gives you information more than what you can find on the data labels or on the axis labels. Make sure the axis labels do have information on them, including units. Okay, you're going to be adding a trend line to the graph, and then thinking about what those values in the trend line. So what does the slope mean? What does that intercept mean? Okay, and so thinking about that. If at any point as you're working through this lab you come up with questions, please don't hesitate to reach out and ask. I'm happy to answer any questions that you may have. Okay? So have a great time making some measurements, doing some conversions, learning about the equipment we're going to be using throughout the course of this lab. Thank you.